Our 12th presenter is Sophia Owutey from the Department of Biomedical Sciences. The presentation title is The Role of SUMO in Labeling and DNA Repair.
You might agree with me that a morning sunshine on a face, it's non-negotiable. Unfortunately, that soothing one could be the start of a silent nightmare. In your cells, sunlight damages your DNA, and that damage could lead to cancer. But why don't we all have cancer? Well, thankfully, our cells have an emergency response group, a team of proteins that rush the damaged DNA to repair and keep us safe. But here's the catch. This repair group cannot come without the right signals. These signals are like a label on an Amazon shipment that dictates its destination. In our cells, these are chemical labels added to proteins to help them work properly. One of these important labels is SUMO. And interestingly, many DNA repair proteins are labeled with SUMO. So my research asks, how does SUMO regulate the DNA repair? SUMO can be added to proteins in two main ways. A single SUMO can be added, or multiple SUMOs added in a chain form to a protein. I study SUMO and DNA repair in yeast because their repair process is remarkably similar to that of humans. This is what I found. When I disrupted SUMO labeling, key repair proteins could no longer assemble at the DNA's damaged site. This suggests that SUMO helps the repair group to gather upon damage. But when I disrupted SUMO chain labeling, the repair protein stayed at a repaired site for a longer time. SUMO chain labeling is likely the signal that tells the repair group to leave after the fix. But why should you care about my research on SUMO and DNA repair? Well, if we understand how SUMO controls DNA repair in yeast, we move closer to understanding cancer development and prevention. Look, my main goal is to identify the key signals that keep our DNA safe, so that one day, simple joys like feeling the morning sunshine will remain exactly as it should be. Warm, peaceful, and free from fear.